Yes.
Can you explain one more time, like the difference between position and velocity? I have a hard time with that. Just I get velocity, but like the position graph is speaking of.
Do you mean like that problem we looked at last time?
Yeah.
Where was that at? That was 3.7 or something like that. So, I mean, when they give you velocity, you can. When they give you velocity, here the velocity itself is increasing, right? Whereas, in fact, if I had a velocity function that looked like this, that velocity is increasing. Yeah. So my position function for that situation might look something like this. Because I'm getting further away faster as time goes on. Does that make sense? I'm speeding up. If my position function looked like this, what's true?
Your velocity is constant.
My velocity is constant because the velocity is the slope of the position function, right? So if my velocity function looks like this, my position function, and this is a straight line, my position function would end up looking like an x squared, right? That's thinking about derivatives in reverse. Whereas if my position function is a straight line, diagonal line, my velocity
just like this
would be constant, exactly, because the slope doesn't change for a straight line. Okay. So when they give you a position function and they're asking you something about the velocity of that position, it's really just looking at the slope at each point. Because the velocity is the derivative of the slope. It's the slope of the position.
So on that velocity one graph up there, the top one you drew, it's going the velocity is increasing in the positive and it's increasing in the negative.
So where's my acceleration positive? Where am I speeding up?
At the middle of the graph, like in between the cut things or whatever.
So here my velocity is 0, and then I'm speeding up all the way up until...
You're slowing down, and then you switch your velocity to the negative.
And then I start to pull back, and then I start to slow down. Yeah. Now I think they do make a distinction, and personally I don't make the distinction, because once you've assigned one direction is positive, one direction is negative, I always think of going backwards as slowing down. But you could make it a lot more complicated and start talking about, well, if you're going backwards, you can actually, when are you increasing your backwards velocity, right? At what point am I stopped? Or points am I stopped?
When the slope is 0 at the peak?
No. When that peak, I am moving along at whatever velocity, let's say that's 50 mile an hour. I'm moving along at 50 mile an hour there. It's just that I start to slow down.
Oh, when you cross the T.
Exactly. So at the roots.
That's where
So that would be stopped. So once I go down here, that is me in reverse. Right? That's me in reverse. So if it went further and went like this is me increasing my reverse velocity, and this is me decreasing my reverse velocity, and that's as much as I'm going to say about that. Because that's just too far removed from what's really important for us in this course. Yeah.
And when you're on the position graph and it crosses T, what does that mean necessarily?
If you're on the position graph?
Yeah.
So if you're on the position graph, well, if you start here, it just means that you've come back.
Your displacement is 0.
Yeah.
So you walked and then came back?
Yeah. Yeah. That's assuming, and this is pretty much assuming that this is a one-dimensional motion. And that's what all the problems talk about is you're moving in one, so I can move, and then I get so far away. I'm at the peak of my distance away, and then I start coming back.
Now, what if it crosses the T into the...
Right there. So that means I would go, so here's where I start. Stay with me. Here's where I start. Now here's where I'm going, and I get as far away as I'm going to get, and then I come back, and then I'm at where I start, and then I go even further back away.
So if you were going like in a circle, would that be like a sine function? Because to be going
If
back.
you're going in a circle, you have to capture somehow the fact that you're actually moving in two. Well, you either have to use the parametric equations, right, and only look at your parametric variable, or you have to allow for the fact that you're actually moving in two dimensions.
Sine function is like.
You guys sort of with me? This problem is assuming I'm moving in one dimension. If the minute I start moving in two dimensions, my graph has to somehow capture that. So we won't worry about that yet. Yeah.
I don't know if it does this in the book, but on the website, when it wants you to take the distance, it makes you do it to 1 at first. Like it wants you to do it to like 1. Function at 1, and then it's absolute value, and then it'll let you go to your like 0 points.
Oh yeah, so when we're collecting how total distance I've traveled, then you do have to, and I think I did it a slightly different way when I did it sort of like the book did, and I think we went like back and then forward or something.
Yeah.
So it's this distance twice, and then it's this distance here. So the book uses absolute values, which makes sense because I don't want to count negative against me, right?
Yeah.
Displacement would say from here to here you've gone nowhere. But what they're asking when they ask that, what's the true distance you've traveled? I don't care if you came back home. If you freaking went around, backpacked around Europe, you've gone some distance. Displacement would say you've gone nowhere. And you're like, shit, I got a lot of pictures with them. So that would be the absolute value equation, saying how much did you actually move? How much did you actually travel? Not just how much did you displace yourself. Does that make sense? So yeah. All right. All right. Anything else? And just to let you know, I mean, I know we have the test coming up, but
How much time do you have?
what's that?
You said anything else? I said, how much time do you have?
Well, about 10 minutes. Chapter 4, I know we have 311 to do after the test is done, but chapter 4 is sort of what I keep talking about every now and again is we know what the first derivative means, but we don't know yet the second derivative, what it means visually, right? And we know what the third derivative means, the acceleration when we're talking about specific position function, but we don't know what it means visually. So chapter 4 is going to feel a lot like pre-calc a little bit, but it's not going to be as intense. We're just going to talk about what do the derivatives tell you, and then we'll be drawing graphs of something based on finding out information from derivatives. So that's really what chapter 4 is going to be like. So anything else?
I gotta use the bathroom.
That's okay. Please do so in the bathroom. I don't know if it helped. All right. That's all I got.
Advice, Jeff.
Huh?
That's good advice.
Yeah.
Can you help me?
Oh. So if you go to mode, you just always want to make sure that everything on the left side is highlighted. So it was in sequence. So if you go back to function, now it'll be back to your normal. Okay. Yeah. You're welcome.